Waalaikumsalam, sir.
Okay, thank you for coming for our last session. Okay, so 1, 2, 3, 4, 5, 6, 7. There are seven students, yeah. Okay, today what we want to learn is only how to model, using Macway, on how to model a beam with a hole, and then on the hole itself you have a load. So I think I want to share something with you. Okay, let's say I create the structure that I want to model will be something like this. This is a beam. Okay, this is a beam, and then you have some hole at the middle of it. Then you have one hole. Okay, and let's say, okay, I have to fill up the hole with certain, okay, and it will be simply supported, yeah. And I have a very simple load which is acting on the top of it. And let's say the load is 1,500 kilonewton. Okay, let's say. And let's say the radius of this hole is about 2 meter. It's quite big. 2 meter. Oh, sorry. 2 meter radius of the hole. Okay, and the distance from okay, let's say this distance. Sorry if the drawing is not up to scale. Let's say that distance is 1 meter. This distance is 1 meter. And let's say the span, the distance from here to the center is 6 meter. And also the other half of it with the same length, 6 meter. It's a quite long beam. And the Young modulus of this, they say the Young modulus is made from concrete. So, sorry, the Young modulus, let's say to be 30 gigapascal, right? 30 gigapascal, because concrete will be in that order, 30 to 35. And the Poisson ratio, let's say to be 0.3, maybe 0.25. Okay, we want to know what is the maximum deflection of this. So what is the maximum deflection? And what is the maximum compressive stress? And the thickness of this beam, okay, ada satu lagi information. The thickness of this beam, let's say 0.5 meter, is quite thick. Okay. Okay, so this is our structure they want to model. It's a beam with a span of 12 meter, and it is under action of load 1,500 kilonewton at the top of it. There is a radius hole with a 2 meter, is quite big, and the distance from the edge of this hole to the edge of the beam at the top and the bottom is 3 meter. So making that the distance from here to the top is to be 3 meter and 3 meter to the downwards there. So it's quite thick beam, and the thickness of the beam is about 0.5 meter. So the solution there is asked from you is to find what is the maximum deflections, so and also the maximum compressive stress. Okay, so as usual we can use our Macway. Okay, macam biasalah. Okay, so in order to model this part, this circular part, so I will use a tools here called as mesh tools, create and split mesh. So there are a lot of tools here, but now I want to introduce you to this a very useful tools called as split mesh. Okay, and you have a lot of options here, whether to model a circle. So you can create a circle using Macway, okay, and you can specify what is the radius of it, okay. And if you want to create a model of concentric circle, meaning you have two circles, so you can define the outer radius, octagon if you have, but for our case is to define our square with circular hole, square with circular holes. And there is a input here requires you to input what is the outer radius. So outer radius meaning that the distance from here, so maybe I have to use my pen is not working. The distance from the center here to the top nodes here, what is the distance here, and that distance we call as the outer radius. So in that case, if we refer back to our word, the distance from the center to the top is 3 meter, because the radius is 2 meter plus this distance to the top distance is 1 meter, so making the outer radius to be 3 meter and the inner radius to be 2. So you can see that it is generated here automatically, and I can control how many mesh density if I want. I can control here. So the more, then you get a larger number of nodes. And remember that in our free version here, our nodes cannot be more than 1,000. So I have to play around within that number. And if let's say you don't want to have you want to have a very preliminary results, you can unclick this, where you can remove all of the mid nodes there. So meaning that your result will be much more less accurate. However, if you click this, then you introduce mid nodes there, that will give you more informations and more accuracy. So for that case, I will maintain this, and I click OK. And then I can view this in XY plane. Okay, and remember that the distance that we have here is from here to here, which is 1 meter. From here to is 3 meter. From here to here is 3 meter, because the distance from here to here is 2 meter and the remaining is 1 meter. So if we carefully see our model, so we have already modeled the 3 meter here. Okay, so meaning that I have to add another 3 meter here, because the length of the beam from the edge to the center is 6 meter. And then we have already modeled the 3 meter here. So in order to model the 3 meter on the left side and the right side, I can click these nodes and change this to be select face. So you can see that the faces now is being selected, and I can extrude. So there is one command here called as extrude. So I can extrude this in the negative X direction, because kita nak tarik dia ke belakang. So negative x directions by the distance of 3. Because we have already from here to here is 3 meter, and the remaining edge ataupun length, we have another 3 meter to be extruded. And then how many divisions? Let's say I want to use 5 number of divisions. So click OK. You may see that now we have the 6 meter on the left side. Similarly, do the same thing on the right side. Sorry, I have to click this first. Select nodes. Select the nodes. Select this edge. And again, extrude lah. Extrude on the positive side of X by 3 meter and by the same number of division, and I click OK. Okay? Can you follow that? So we have already created our beam as in this case. So please remember, this drawing is not up to the scale. However, the drawing here is up to the scale. Okay? So that's why you can see that our beam is more elongated. It should be not so elongated, but it's like a very short and bulky beam. So far, any questions? Is there any questions?
No, sir. Not yet.
Okay. Next is to define our material properties lah. Your Young modulus, Poisson ratio, and the thickness lah. So as usual, we just click these 72 elements. Before we do that, check the number of the nodes. Is it more than 1,000? Hopefully, it's not more than 1,000. It's okay. Because this is a free version, that is our limitation. Okay, click this 72 elements and assign new materials. This is 0.5, the thickness, and it is isotropic in the gigapascal. Concrete is about 30, and the Poisson ratio is 0.25. So just click OK. And the material properties has been assigned. Okay. Next is to define as usual our support condition, where these two support condition can be selected, and then we can define the loads and constraint under the new displacement, where our x here to be 0 displacement. You may see that our x here to be constraint, and also our y also to be constraint. Okay. And after that, I want to select this point because this point will be subjected to 1,500 kilonewton. So as usual, click under loads and constraint, new force, which is in the y direction. Remember, our positive direction of y is upwards. So here will be the new kilonewtons, and this will be negative 1.5, right? Sorry, 1.5, right? Okay, so select this static 3D to static 2D, CCX. Click OK, and save the file first. Let's say this is to be beam with hole. Okay, run it. There's no problems. So if you want to know the maximum deflections, so for sure the deflection will be in the y directions. So I can click in the y directions. So you can see that the maximum deflections here all are in negative, meaning that all are acting downwards lah. So the maximum deflection is the, so maybe I change this to be millimeter. Okay, the maximum deflection with the blue color, okay, which is negative. So this is micro, micro kecil sangat, millimeter okay sikit. Okay, so the maximum deflection is about negative 0.8493, which is somewhere here. And if you want to see the deform shape, you can view that. So you may see that the deformation from, sorry, if I click this, from this portion to this portion, the deflection is about negative 0.85 lah millimeter. Okay? And if you want to see the animation, as usual, you can view the animation. You can see that the hole is being deformed by the loads. You can see that the shape of the hole is circular here, but now it's being pushed downwards. So seems to be is being to be compressed by 1,500 kilonewton, so that the maximum deflections will be 0.85 millimeter downwards. So there is a very small deflection here, logic, because this is where you have apa ni pin jointed zero, which is blue red color here, and there is also less deformations here, which is about negative 0.09, but a very fast moving here because it's being deflected. Okay, so how about the stresses? You can click the stress, and the stress that you want to view here is the stress in the vertical direction, which is Y. Okay, so maybe I want to change this from Pascal to maybe mega lah. Mega much more pronounced. And you can see that the stresses in Y directions, okay, you have a compression force somewhere here because the color is blue and the value is negative. So it's a very maximum compression force here, which is about 6.6 megapascal, and a very low stress here, which is in tensile, dekat atas ni, is about 0.6 something megapascal. So you have a lot of stresses which is underneath the load. And when reaching to the the edge of the circle or the circular part, the stresses convert from compression to tension, and the stress is quite low because the color of the red is at the top, meaning that it's the lowest, sorry, it's the largest compressive strength, tensile strength. The lowest compressive strength is the color of green, orange. So the orange color is the lowest compression stress. So if you want to see the shear stress, I can click the XY. This is the shear stress. Okay, you may see that the shear stress is quite dominated by zero values here. So meaning that the stress of shear is quite low. And if I view the thickness, so if you view in 3D, okay, so maybe I want to make this one to be zoom, and I can zoom to the part that I want to zoom, okay, and then I can rotate if you want to study this area. So this part having a compression force because the color is blue between 1.3 to 2.1 kilonewton, newton megapascal. So you have compression shear stress here, whereas you have a tensile shear stress here. Okay, any questions for this? This is a very useful tools if you use the mesh tools under create and under split mesh. So is there any of the group have a problem like this where you have to create a circular part on your structure? Ada tak?
Ada sir, my group.
Okay, so hopefully this can give you some guidelines lah on how to create the circular segment lah on your parts, and then you can extrude which part that needs extension kalau ada lah. Is this presentation is clear? Is it clear?
Sir.
Yep.
Kalau ada lebih pada satu
lubang.
Lubang.
Kita boleh buat multiple lah.
Macam mana sir?
Kita boleh buat multiple lah. Contohnya kalau saya buang ni, edit, kita select all, kita buang. So if you have two kind of holes, so you have to create two kind of holes. So katalah yang macam ni Okay. So let's say the outer radius is 1. The inner radius, kalau kita terima lah yang ni Okay. So maybe kita boleh pusing dulu. Sorry. Okay. So it's better kalau you ada lagi satu lubang sebelah kanan. Sekejap saya kena buang dia punya kantar. Kita kena mengganggu dah. Okay. Alamak. Okay. So better you move this. Okay. You move this, select all. And then you can move this. Mana move kat sini? Move. Nampak ni? You have move. So let's say I move in the X direction, katalah sebanyak -1. Okay. And let's say now I create another mesh tools, create split mesh. So this one. So katalah dia punya outer radius tak sama. Katalah outer radius to be 3. And inner to be, okay. Yang ini agak sukar sikit. So better kalau jadi begini kan. Saya namakan ni dulu. Saya namakan ni, kita right click. Kita boleh add element to new component. Kita bagi nama dia dulu. Mana benda ni? Okay, sebab saya rename ini. Katalah ini hole number 1. Okay. And kita boleh hide ni, nampak ni? Saya boleh hide ni, nampak ni? And then kita boleh show all. Okay. Okay, so itu kepentingan kita buat hide and hide, and then kita buat apa ni? Kita buat nama. Okay, so kita buat mesh tool lagi sekali. Okay, katalah saya gunakan yang sama juga. Katalah yang ini dia punya, ini 3 outer, yang ni inner katalah 2. Okay, sekarang dah bercampur kan? So saya namakan ni yang kedua ni dulu, namakan dulu, rename, katalah ni hole number 2. Okay, kita hide dulu yang ni dulu. Kita hide yang ini. Nampak? So yang ni saya boleh move ke tempat lain. Mana tadi move? Saya boleh move katalah ke arah, katalah 4 meter sebelah kanan. Okay. And then kita show semua sekali. Nampak tak? Sekarang kita boleh buat 2. And then sekarang ni kita boleh move benda ni kepada mana tempat yang kita nak. Faham tak? Faham tak kenapa saya buat 2 ni, and then saya hide satu supaya kita boleh padam satu ni, and then kita boleh create satu lagi.
Faham sir.
Faham kan? Macam itulah yang buat.
Okay. Alright sir, thank you.
Yes, so at least bagi some kind of guideline lah. Yang lain tu lebih pada kreativiti lah. Sebab lepas ni you nak kena cantum ini ni. You nak kena cantum ini ke sana kan. So you nak cantum ni terpaksa lah you gunakan line element lo. Ni kena cantum lah. Macam nampak? Ini kena cantum secara manual lah. Nampak? Kena cantum secara manual lah. Contohlah kalau lubang sebelah kiri ni kecil, sebelah kanan ni besar, terpaksa buat separate, and then tengah-tengah ni ada transition, tengah-tengah ni kena cantum dengan secara manual. Boleh
Boleh sir.
Kalau kata nak cantum gunakan yang kuat ni pun boleh tak? Nampak? Tapi bila ada pangkal ni maksud ada salah lah. Ada benda tak betul. Okay, boleh Ada apa-apa tak persoalan lagi? Tentang projek yang mana ada masalah? Selain daripada masalah lubang ni. Nampak saya boleh hide wall lubang mana yang saya nak hide then saya boleh activate balik. Nampak saya boleh hidupkan balik Yang ni pun sama, saya boleh hide and then saya boleh show balik dia saja. Nampak? So maksudnya kalau you ada structure tu, you boleh hide and show tu mana-mana elemen yang you nak. Jadi you senang nak manage. Kalau tidak nanti you buat serentak semua, kacau bilau nanti nak uruskan dia punya meshing semua tu. Faham Setakat ni ada soalan?
Tak ada, sir.
Ada tak problem lagi yang complicated yang you tak boleh model? Problem project. Setakat lubang ni kita dah selesai dah. Adalah tak lain. Saya rasa lebih kurang sama je lain pun.
Sir.
Ya.
Kalau hole tu dia shape dia macam petak ke macam ni circular kan, kalau contoh hole dia petak.
Segi empat.
Ha.
Okey, segi empat macam ni. Segi empat terpaksalah you buat secara manual. Okey, contohnya create split mesh. Okey. Kalau you tengok betul-betul kalau saya buat katalah peta so kalau saya buat ini menjadi 4, nampak dia akan jadi peta so kalau ratio outer to kalau cuba tengok kalau saya letak ini 8, ini nampak jadi bulat so kalau ratio outer to inner 2 dan ke atas, dia akan jadi bulat. Tapi kalau outer to inner is less than 2, katalah 1, dia akan jadi kotak. Nampak? Nampak tak? Okay, tu satu cara. Cara keduanya terpaksalah you buat manual lah. So maybe kalau you nak manual tu terpaksa buat kotak macam biasa lah. You kena buat coordinates macam biasa. Kan? You terpaksa buat kotak macam biasa lah. So kalau kata inilah you punya lubang tu begini, terpaksa buat manual lah. Ni cara kedua lah. So selepas tu you cantum macam ni. Terpaksa buat manual. Okay. Yang tadi special kalau circular tengah-tengah. Senang sikit lah. Sebab circular you tak ada peluang nak buat macam ni. Sebab ini senang-senangan. 4cc ni boleh dibuat. Tapi kalau circular macam ni nak buat. Sebab itu dia ada tools ni. Mesh tool under ni. Supaya boleh create circular ni. Segi 4 you boleh buat manual. Faham
Okay sir, faham.
Segi 4 boleh buat manual. Bulat memang sukar lah. Sebab you nak control tu supaya jadi hampir-hampir bulat memang sukar. Unless you have a tools lah. Setakat ni ada tak lagi? Selain daripada ni, problem lain. Okay, if you see carefully, you ada satu features yang nama sebagai import So kalau you click on the import, okay, kalau you ada X, Y, Z point, you boleh import that point and then dia akan terus lukis tau. Pun boleh juga tau. Faham tak? Maksudnya you buat pakai pakai notepad, you letak point X, Y, Z tu, okay, and then you import je, and then point tu akan imported, dia akan terus tulis dot kat sini. Faham tak? Sebab maybe sometimes you calculate that point by using Excel. So that point you malas nak plot, you cuma senaraikan je point tu, and then you boleh import saja point tu. Pun boleh juga nak lukis. Tak payah kita nak lukis dalam ni. Okay, nampak ni. Yang lain kalau kata you ada abacus, you boleh guna abacus juga. You boleh draw by using abacus. Ataupun pakai AutoCAD pun boleh. Let's say the structure tu, you lukis pakai AutoCAD kan, kadang you dapat projek kan, structure kan pelik-pelik kan gambar dia kan. So you lukis pakai AutoCAD and then you export as DXF Dalam AutoCAD you export sebagai DXF. So bila you buka dalam Macway, you kena import that DXF file. Kalau you pakai AutoCAD lah. So nampak tak, you ada banyak input tools supaya memudahkan you nak modeling. So kalau kata ada certain project saya tengok gambar aja dia agak complicated. So why not you use AutoCAD, lukis pakai AutoCAD, and then export as DXF, and then buka apa ni Macway, and then import saja dia punya DXF file. Senang. So tak payahlah you nak lukis tu dalam Macway. You lukis dalam AutoCAD pun boleh juga. So nampaknya Macway ni is a very user-friendly software lah, because it make your life easier rather than to create the point lah. Macam ni nak buat satu-satu letih kan. Kalau you ada 1000 point, yang mana maksimum dalam pun 1000 ya boleh kan. Kalau you ada 1000 point, tak mungkin you nak plot, you nak lukis sesuatu sini kan. It's better you use AutoCAD and then you boleh import. Okay. Kalau nak cuba boleh cubalah yang tu. Import dari AutoCAD. It's not a problem. You can import. Ada questions? Adakah sebarang soalan lain? Is there any questions?
No sir, setakat ni tak ada.
No, sir.
Okay, if there is no question, I think this is our last class for laboratory part lah. And please to note that you have test 2, and before you have test 2, we will check your exit survey. So if anyone do not conduct any exit survey, then you cannot do your test 2. So please do that. And please ask also Puan Nurlizan the date of the test 2. And if you some of you have replied that done your exit survey, thank you. So please do that, because this will be the gate whether you can enter test 2 or not. Okay, if there is no question, I think we will end up our session. Okay, so I just want to thanks for all your participation up to now. So forgive me if I have any wrong words. If I'm harsh to you, that is how I educate you so that you can understand the course. Okay, and please do not forget also to tick your future, you punya antennas lah macam biasa after this. Okay, so we will see again maybe next semester. Okay, and good luck to your test 2. Please do the exit survey. Okay, thank you. And please also submit your project on the date required by the task. Okay, do not forget about that part. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, thank you sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.